Good morning, guys. Today we're going to look at our last conic section. This is the parabola. This is the conic that comes from passing a plane parallel to the side, to one side of the cone, so that it passes through the other side of the cone and the base of the cone. So we get this curve right here. It looks like half of a hyperbola, and that's sort of true because we're not turning all the way up to where we intersect the other cone. So this is the curve of the parabola. It's the set of points that are equidistant from a fixed point, which we call the focus, and a fixed line, which we call the directrix. So the definition says distance from a point to the focus is equal to distance from a point to the directrix, which would be the closest point on that. So if we were looking at what we have here, if I have this point here, and I drew a line all the way to my focus, the distance from the point to the focus is equal to the distance from the point down to this line, the directrix. So those two distances should be equivalent. So as you can see, my graph's not quite a parabola. I would have to open it up a little bit more. But that's the truth. It's not the same distance like we had with the ellipse and the hyperbola, where it was the sum of different distances, or sum of different, let's try it again, the sum of distances, or the difference of distances with constant, or with a circle where it's the same distance. What it's saying is that the distance from the focus to any point and the directrix to any point is always going to be equivalent. So it doesn't matter what the point is, the distances between that point and those two figures is always constant. So we get this really special point right here in the middle between these two, the center, I guess you could call it, of the directrix and the focus, and we call that the vertex. It's the same vertex we had when we were graphing quadratics, because the parabola is still the graph of our quadratic function, our quadratic polynomial. We're just looking at it in a little different manner, different way to get there. Instead of just taking a bunch of points and saying they have a quadratic relationship, we're actually getting it from passing a plane through the side of a cone to get a conic section. So it's the exact same relationship for those two different things. Now, the different ways we can do this is, remember before when we graphed quadratic polynomials that either opened upward or downward because we were talking about quadratic functions. With a conic section, we know that they're not functions always necessarily, so we could turn them in any direction. So we're going to focus on when they're going left and right or up and down. The up and down is the same formula we had before. We're calling it standard form now, which I know can be a little bit confusing because standard form for quadratics earlier, as you remember, was y equals ax squared plus bx plus c. Well, that's standard form of a quadratic function. We're talking about the standard form of a parabola. So a little bit of a distinction there. And what it actually looks like is our vertex form of a quadratic function. So this is the standard form where we've identified where our vertex is. H and K are the vertex. See, H and K are the vertex. So it doesn't matter which one's being squared. That doesn't change what our vertex is. And A, just like we had before, A is the coefficient of the squared term. That's going to tell us how to shape this graph. So the way we shape this graph is that A is always equal to 1 over 4D. 1 over this distance between the vertex and the focus. And the reason I put the D as the distance from vertex to focus is because it really gives us the direction. If you'll remember before with quadratic functions, if A was positive, our graph opened upward. If A was negative, our graph opened downward. Well, it's the same idea. If A is positive, then to go from the vertex, we're going to add that D value to get to our focus. And that's going to tell us if we added vertically, it would open our graph upwards. If we added horizontally, it would open our graph to the right. Well, if D came out to be a negative number because A was negative, then that would point our graph either left or down. So I always, and people will do this differently. Some people will say it's the absolute value of D or the absolute value of A, and then we'll do a little bit of reasoning. I like to think of D gets me from vertex to focus, in that order. Starting at the vertex gets me to the focus, and that takes care of my direction. And then I'm going to go in the opposite direction, so same distance but opposite direction to get to my directrix. So directrix is either going to be a horizontal line as we get in the opens up or down, or it's going to be a vertical line as we get in the opens left and right. So what we should recognize, hopefully, is that if we have opens up and down like this graph does, we have a y equals a times x minus, or a y equals x squared type of equation. We have a y equals directrix. If we have an x minus h, or an x equals a times y squared, if we have an x equals equation, then the directrix is going to be vertical because the graph is horizontal. So we would get an x equals. So if you'll keep that in mind, y equals graph gives us a y equals directrix. An x equals graph will give us an x equals directrix. That'll help you keep a lot of that information organized. And then when you put it on the graph, it all kinds of starts to make sense and fit together and check each other anyways. So that's all the information as far as how wide to graph, because we're not going to focus a lot in this course in Algebra 2 or in trig, or sorry, on exactly how wide to draw this. But if I wanted to get a little more in detail, I'll just talk about this briefly. If I want to get a little more in detail about this, this distance right here, or this line that runs parallel to the directrix through the focus, but parallel to the directrix and ends on the parabola. This line right here is called the latus rectum. And the latus rectum is just as I said. It's a horizontal line segment that runs parallel to the directrix through the focus and ends on the curve, on the parabola. Why it's important is because it tells us we have a way to figure out how wide that line is. So if I know how wide that line is, I get my 3 points to be able to give myself a good curve. The width of the latus rectum, is equal to 2 times the focal parameter. Well, 2 times the focal parameter, what the heck's the focal parameter? Focal parameter is the distance is this distance right here. So I'm going to put it straight out there. The focal parameter is the distance from the focus to directrix. Like we said earlier, our D was from vertex to focus. Well, focal parameter is from directrix up to focus. So it's that distance there together. So it all kind of fits back into what we were doing. So what we can see is if the focal parameter is this distance, well, this distance is 2Ds, correct? And the latus rectum is 2 focal parameters, so the latus rectum is actually 4Ds, which is what we can see right here. A is equal to 1 over 4D. We're doing, remember, reciprocal your transformations, and so we can see that we're horizontally, we would draw a point through the, or we would draw points on the focus either side, and you would do 2Ds to the left, 2Ds to the right, and 2Ds down, and that would give you all of your necessary points. So you don't have to do that. It's just some stuff that you'll encounter in future courses where you will work with the focal parameter and the latus rectum, just to give you an idea of some terminology. But what I'm focused on is, can we get the directrix and focus and vertex drawn and make sure our graph's going in the correct direction? So as you go into pre-calculus, calculus, you'll focus on that terminology and give it a little more precise graph. But this is the information that I really care about, being identifiable. Like I said, being able to identify focus, directrix, and vertex. All right, give me a second. I'll get some examples up here, and we'll graph a few parabolas. So here I have a couple of examples for you. So let's start putting it together. Let's start by identifying the vertex. Vertex is x-coordinate, then y-coordinate. So we notice we have our x-coordinate is going to be 4, because we do the opposite of h. So sorry, negative 4 is the opposite of h, so we'd go with positive 4. Minus 2, that's the opposite of k, so we're going to go with positive 2, so there's our vertex. Focus is going to be identifying the directrix. So first off, we make sure that we're actually in standard form where we have the linear term is equal to a times the quadratic term, which we do have. I've got to the first, then I've got my a, then I've got my square, my quadratic term. So since we have that, we know that this is indeed a, so a is equal to negative 1 over 16, which we know is also equal to 1 over 4d. So you do a little cross multiply and divide, you get negative 4d equals 16. So d is equal to negative 4. So that's going to tell me how to get my focus. Now, because this is a y equals, y is linear, then my y coordinate is what's going to change. It's y to the first, so my y coordinates will change. I'm going to have a vertical graph right here. So my focus is 4, 2 plus negative 4. And my directrix is going to be y equals the y coordinate minus negative 4. All right? So whatever d is, we add it. So just take d as it is. Leave the sign with it and everything. So as I said before, because d tells us the distance and direction from vertex to focus, we just add it onto our vertex. So since it's the y, this is a y equals graph, we're going to be focused on the y coordinates. So we take our y coordinate plus d, and then we take our y coordinate minus d. Now remember, focus is a point, so this one will come out to be 4, negative 2. Directrix is a line, so it's going to always be a y equals or x equals equation. So that's going to be y equals 6. So if I go through, put all this on the graph, vertex is 4, 2. Focus, I'm going, from here I'm going down 4 units. That's what d equals negative 4 was, which is 4, negative 2, which we have. And then my directrix, I've got to go from the vertex, go up 4 units. And it's a horizontal line. We'll draw our curve. It'll be something like that. Man, that's terrible, but you get the idea. Some kind of parabola of that nature. Again, we could take this d and double it and give us 2 points, a point out here, double it again, give us a point out there to give us a little bit better curve, but I'm not going to expect that much from you guys, or require that much. I know y'all could do that, but just, if I want you to be able to identify and get it going in the right direction, and not so much worry about exactly how wide and all that stuff is. You've given pretty good indicators if you got that. So we got a vertex, got our focus, got our directrix, and we were able to put it all together to make a curve, to make a parabola. All right, pause the lecture here, take a couple minutes. I want you to come up with the graph for that parabola. Okay, hopefully you were able to come up with a graph for this parabola. Let's take a look at it. First, we'll double check, make sure we're in standard form. I have linear equals a times quadratic, so we're good to go there. Let's identify the vertex. It's the x coordinate first, so opposite of positive 1 is negative 1. Opposite of negative 3 is positive 3, so there is our vertex. Focus, I need to identify what d is. So we first look at a. A is 1/2. And we know that should be 1 over 4d. So 1 over 4d, just go through, do a little cross multiply, 4d equals 2, so d equals 1/2. So to get our focus, we're going to take our vertex and add 1/2 onto which coordinate? Well, since x is the linear coordinate, x is linear, then we're going to add it onto the x coordinate. That tells us that this is going to be a horizontal graph. So it's our x coordinates that are going to change. Y coordinate does not get impacted. So we get negative 1 plus 1/2 is negative 1/2, comma 3. Directrix, we're going to go the other way. Again, x is the linear term, so we're going to go x equals, and we're going to do our x coordinate minus our d, which is 1/2. So we get x equals -3/2. Now, from there we just put it all together on the graph. So vertex is at -1, 3. The focus is going to be at -1/2, 3, which would be just inside of it. And the directrix is at -3/2, 3. So it's all kind of squished in there together. And then we just draw it. So remember, directrix is your vertical line, or is your line. So we're just going to draw it going to the right, which makes sense because we had a positive D, positive A, so we should have a positive graph. So it'd be a graph going to the right. So this is our parabola for that. And again, you can write the graph, have your tick marks, all that stuff so that it's clearly marked. And then you just make a list with your actual, this is vertex, this is focus, this is directrix. We don't have to cram it all on there. Now, number 3 over there is one that's not written in standard form. So let's do that one together and get it into standard form and then go through and graph it. So remember, we're going to do these by completing the square. So I'm going to start out getting my like terms together, so which we already have. We have our y's together, we have our x together, and so on. So we want to complete the square on this y portion. We'll lead coefficient of 1. We're good there. So we need to add to the y's b over 2 squared. So I need to put a b over 2 squared in there. So that's -8 over 2 squared plus 8x equals 16. And with all equations, you have to balance it by doing the same thing on the other side. So plus -8 over 2 squared. Let's check out. I think it's supposed to be a negative. There we go. -16 is what that's supposed to be. Okay. I'm not messing with the x because I don't have any other x's. So there's no square on the x's to complete. X is our linear term in this case. So we'll go through y squared minus 8y equals, plus -4 over 2, -8 over 2 is -4, squared is 16, plus 8x equals -16 plus 16. So we're going to get y minus 4 and y minus 4, so y minus 4 quantity squared plus 8x equals 0. So we're almost into standard form. So get the linear term by itself, so we can subtract the 8x over. It's pretty easy to move. So we get -8x equals y minus 4 quantity squared. We're not quite into standard form yet because my x has a coefficient on it. And remember, with standard form, we want the coefficient to be on the quadratic term, not the linear term. So we're going to divide that -8 over. So now we are at x equals -1/8. That's how I would look at it so that it's easy to compare it to the 1 over 4d. Y minus 4 quantity squared. So we want to get the linear term by itself. Now we can go through what's our vertex. X coordinate has no shift on it, so it's 0. Y coordinate does have a shift on it, so that's going to be 4. Focus. We're going to take our A, so -1/8. I could get my mouth, hand, and brain all on the same page. -1/8 is equal to 1 over 4d. Cross multiply, -4d equals 8. Divide by -4, so d equals -2. So my directrix, because x is linear, is going to work off of the x coordinate. So 0 plus -2 is going to give us -2, 4. For the directrix, we go in the opposite direction. So directrix, we're still at x equals, so it's x equals the x coordinate. And we're going to go minus -2, so x equals +2. Put it all together on a graph. So we get vertex is at 0, 4. Focus, we're going to go down 2 units. Directrix, we're going to go up 2 units. And so that is our curve. That's our parabola for that function. So remember, use your completing the square to work on your squared terms and then get it into standard form. Remember, a linear term equals a times the quadratic term. Okay, that's it for graphing parabolas in standard form, and I will see you in class tomorrow, guys.